Hello everyone. In this session we will discuss some problems regarding the BJT. Last session we will discuss some problems, but we will discuss some basic problems and very important for the BJT. The first problem is for silicon NPN transistor, the base emitter voltage VBE equal 0.7 volts and the collector to base voltage VCB equal minus 0.8 volts. Then the transistor is operating in A. Forward active region, B. Reverse active region, C. Saturation region, D. Cutoff region. He is asking which region it is. So here first, given transistor is NPN transistor, that is okay. And so first just draw a transistor to understand this. This is the, I will take NPN transistor means, so collector is N and base is P, again emitter is N. So this is the NPN transistor. So take it is a collector and it is a base and it is a emitter. How we can say that? The emitter has the signal, emitter has the symbol like this, and this symbol is coming from P type material to N type material. Symbol is like this, current flow is like this. And he mentioned base to emitter voltage equal 0.7 volt. Look at here, this is the base to emitter voltage. So this voltage is 0.7 volts. Yes. And collector to base voltage, base emitter voltage equal to 0.7 volts. Collector to base voltage VCB equal minus 0.8 volts, given minus 0.8 volts. From this I can write VBC equal 0.8 volts. Okay, VBC equal 0.8 volts. That means between B and C is 0.8 volts. This is the plus and this is the minus. So this is also 0.8 volts. This is the plus, this is the minus. Look at here. We are giving, so observing these two voltages, it will take as he given VBE base here and VCB base here. So we can consider it is the common base BJT. Just you take it, it is the common base BJT. Why we are considering the common base? In VBE base is common and VBC base is common in these two common bases. So maybe this is the common base signal. So whenever the common base is there, generally input is the emitter, output is the collector. Look at here, for input side, for input we are giving for positive, for P positive input and for N we are giving negative. This is the input is forward biased. What about output? Output you can take collector also here. Here the for collector is N will take the negative. So that means output is also the forward bias. When input and output both are in forward bias, automatically the transistor in the region of saturation region. So it will be acts as a on switch. Okay. So this will be, the solution is the saturation region. So in the exam, if you give any problem like this, just check the given biasing in forward bias or reverse bias. Then you decide which region the transistor will be in acting. Okay. Next problem. Here the next problem is for BJT, IC equal 5 milliamperes, IB equal 50 microfarad and ICBO equal 0.5 microamperes. Find the values of beta and emitter current. So this is the question. First, write down the given data. So in this given data, he given collector current equal to 5 milliamperes first thing. So this is the 5 milliamperes, and he given base current is 50 microamperes and common base leakage current equal to 0.5 microamperes. Okay, so we can directly find out first emitter current. First is the we can find out the emitter current. How we can find out the emitter current? Emitter current is nothing but base current plus the collector current. So what is the base current here? Base current is 50 micro, collector current is also 5 milli. By combining together, we will get the emitter current value is 5.05 milliamperes. So whenever he is giving to find out the beta and IE, first you will go for find out the emitter current. Next, what is the need? We need beta. So in order to find out the beta, you know that the common emitter connection, the common emitter configuration, the output current equal, the common emitter current, which is output current, collector current equal to amplification factor into base current plus common emitter leakage current, plus beta into IB. But we have a relation, that is in the given problem he mentioned ICBO. There is a relation between common emitter leakage current and common base leakage current. That is, common emitter leakage current will be equal to the 1 plus beta times of the common base leakage current. Just substitute in the above equation. So from that we will get IC equal beta into IB, and here 1 plus beta into common base leakage current. Okay, from this we can write, so we will extend this IC equal beta into IB plus ICBO plus beta into ICBO. So just common the beta and separate the terms here. So from this we can write here, just separate the term here. Here we can, by separating the beta, I will write, this is the separate term, IC minus ICBO, and if you common the beta common IB plus ICBO. From this we can find out the beta value equal current minus common base leakage current by base current plus common base leakage current. So what is this current? Actually IC. This is also IC. So from this we can write the beta value equal, what is collector current here? Collector current equal 5 milliamps. So 5 milli minus leakage current, ICBO is 0.5 micro by base current IB is 50 micro plus ICBO, this is the 0.5 micro. 50 micro plus 0.5 micro. So by solving this we will get beta value equal to 99. So whenever he is given IC and IB and ICBO like this, first you will find out the I. Then by using the formula of IC current formula, then you will find out the value of the current amplification factor, beta. Okay, this is the procedure to find out. And the next problem, here this is the next problem. The next problem is, consider the transistor the next problem. Yeah, consider the transistor circuit shown in below. This is the transistor circuit. Look at here. Beta equal 50. The transistor is operating in active region, B cutoff region, C saturation region, D none of the above. So in this type of method, first you will take given data. The given data equal to beta equal to 50 is the first point. The given data is 50. Okay, here and in the diagram, this is the emitter current. The emitter current equaled 1.2 milliamps, and the collector current equal to 1 milliamp. Okay, so to verify this, first we will find out the base current. Given this is the given beta, don't forget this is the given beta. First you find out the base current. So for that purpose, emitter current equal to base current plus collector current. So from this I will write the base current equal to emitter current minus collector current. So here the base current value equal to emitter current equal 1.2 milliamps minus collector current equal to 1 milliamp. So by doing this we will find out the base current equal to 0.2 milliamps. So we have the base current, that is the 0.2 milliamps, right? Now we have the base current and given collector current equal to this. So by using these two currents we will find out another beta. How? Generally collector current equal to, we can write beta into IB. Just to verify is it correct or not. So this is another beta, that's why you take it beta dash. We have to find out this beta dash. Then we are finding the beta dash value equal collector current by base current. So from this beta dash equal the collector current value equal 1 milli and the base current value equal to 0.2 milli. Just doing this, and by solving this we will get 1 by 0.2. 1 by 0.2 means 2 5 times. Then beta dash equal to 5. Beta dash equal to 5. So look at here. The given beta is, actual beta is 50. But by using the currents we are finding the beta value, beta dash equal to 5. Whenever the finding beta dash value is less than beta, then that what is this meaning? The meaning, we can write a statement. The statement is for given current we are getting amplification factor beta dash is less than nominal value. Is less than nominal value. What is the meaning? What is the nominal value? Nominal value is nothing but given beta. Nominal value is nothing but the given beta. So whenever the finding beta value less than beta, then the BJT will be acting in the saturation region, operated in saturation region. So this is very important problem. In the question he mentioned some beta value, but by using the currents we are getting another beta value. So given nominal beta value, whenever nominal beta value higher than the calculated beta value, then BJT operated in saturation region. Saturation region. This is very important thing. And we will do the problem in another method also. The second method. So here the second method also we will do the problem. So what is the second method here? you know the collector current equal generally beta into base current. Here we will doing like that model. So by using given beta is generally 50 and base current is 0.2. Okay, using that, so in the given problem is 50, base current is the 0.2, the collector current we have to find out. Then we will get the collector current value equal 50 into 0.2, you will get 10 milliamps. 10 milliamps here also, but in problem given collector current equal, actually it is the 1 milliamps only. 1 milliamp only, actually the given collector current is only 1 milliamp. This is also same. Whenever the calculated current value, this is the calculated, that value is 10 milliamperes is greater than nominal, or you can take nominal collector current value, then BJT is operated in saturation region. BJT is operated in saturation region. This is also the important thing. Okay, to maintain, in order to find out the saturation region, first you can proceed by calculating beta, one method. The another method you can finding by the collector current. By using these two methods we can find out the given BJT in saturation region or not. And we will go for the next problem. Here for the given circuit, the voltage difference between the collector and emitter voltage is, so he given some circuit, he asking to find out the emitter and voltage difference. That means he is asking to find out the VCE value. VCE value. So here doing this thing, first observe the diagram. Here this is the collector point, this is the base point, and it has a symbol, that's why it is the emitter point. So he is asking to find out the VCE, that means the voltage, VCE means the voltage difference between collector and emitter. That means VCE is nothing but VC minus VE, drop between this point and this point. So for that purpose, just we need to calculate the base current and the collector current. So look at here, base is connected to ground. Actually here base is connected to ground means, just observe here, base is connected to ground, that means the base current is 0. Here we can write the base current is 0. So you know that the relation between collector current and base current, what is? Beta into IB. Substituting this, you will get the collector current also the 0. That means there is no collector current. There is no collector current. Okay. Yes. There is no collector current. And the base current is 0, and here you know that base current we have some beta, he is not given beta, and we can write collector current is approximately equal to the emitter current. He given beta, I assume beta is very high, beta is not given, beta is very high. So that in that case collector current approximately equal to the emitter current, we know that. Here collector current is 0, what about the current flowing through the emitter current? Also 0. So we can write emitter current also the 0, because collector current will flow through the emitter. Okay, base current is also 0, that's why emitter current is 0. Yes, and so this is the emitter current flowing through the circuit, right? And we can find out the drop across this point. What is the drop across this point? This point voltage equal the voltage across the 2 kilo ohm resistor. So I will write VE equal to IE into RE. IE is 0 and we have RE, then it become 0. So voltage across E point also 0. Next, what about voltage this point? So this point voltage equal, so we can write the voltage between voltage across this point equal, I will write like this, 5 minus, so voltage across this point means this supply minus this drop. So VC equal, the supply is 5 volts, the drop across this is collector current into 1 kilo ohm. So here the collector current is 0, we know that the collector current is 0, then automatically it is the 5 volts. So therefore the VCE equal VC minus V. So VC is 5 minus 0, therefore VCE equal to 5 volts. VCE equal to 5 volts. Okay, so this is a simple method. In order to calculate the voltage difference between, use the all the transistor formulas. Okay, and go for the next problem. Here this is the next problem. The given problem is for NPN BJT having reverse saturation current IS equal 10 power minus 15 amperes. So first write the given data. Given data, reverse saturation current, you can name it IS, that is 10 power minus 15 amperes, is biased in the forward active region at room temperature. VBE equal 700 millivolts. So we can write the 0.7 volts. VBE equal 0.7 volts. The current gain beta is varies from 50 to 150. So is given variation 50 to 150, two values due to the manufacturing variation. The maximum emitter current in microamperes. So we are asking to emitter current, but it is the maximum emitter current. Okay, so this is the question, given question. So here in this type of questions, simply we can, generally we know that the collector current, output current, we can write like this. The collector current equaled reverse saturation current into exponential of VBE by VT. VBE means base emitter voltage, I is reverse saturation current. What is VT? VT is thermal voltage of BJT. Thermal voltage of BJT. So what is this value? That value is 26 millivolts. And we have this formula VT equal to KT by Q. K is the temperature constant, T is the temperature, Q is the charge of the BJT. So substitute all the values. The collector current IC equal to, here reverse saturation current is 10 power minus 15 and exponential of, what is VBE? VBE is 0.7 and VT equal 26. So both are milli and milli. Just do the calculation. We will get the collector current IC value equal 492.66 microamperes. 66 microamperes. So we have a, but what is he's asking to find out? Emitter current. Actually he's asking to find out the emitter current. So what is the formula for emitter current? Emitter current equal generally with the relation between emitter current and collector current equal emitter current. So we know that the collector current equal to alpha into emitter current. This is the formula. Okay, so here and we have a relation between alpha and beta. Alpha equal to, we can write like this, beta by beta plus 1. Okay, so here now the emitter current equal 1 by alpha into IC. So 1 by alpha means we can write beta plus 1 by beta into IC. Okay, so emitter current equal, this is the formula. That formula is emitter current equal beta plus 1 by beta into collector current. This is the formula. So here the relation between the emitter current and collector current is like this. We have the collector current and we need to find out the emitter current. But beta have two values. One is 50, another one is 150. 50 and another one is the 150. Here just observe here, maximum current will have the minimum beta. Whenever the minimum beta we have the maximum current. So maximum current IE will be get by minimum beta. So minimum beta value. So what is the minimum beta in this 50 and 150? 50 is the minimum beta. Just write it 5 and 50 plus 1 by 50 into IC. What is IC value? Here IC value equal, here the IC value equal 492.66 microamperes. Substitute here 492.66 microamperes. By doing the calculation we will get the emitter current value equal 502.51 microamperes. 51 microamperes. Okay, so this is the another type of model of BJT. Here he is giving the input voltage and he is asking to find out the output current. Okay, and this is the procedure. Okay, I hope all of you enjoyed the session. I think all of you understand the models. These are the different models of the transistor. Okay, these are the very important in the view of the competitive exams also. Okay, thank you.